Welcome to the video about area and perimeter and circumference. All of the formulas on this video are also on this pink reference sheet that the 11th graders use when they take the kneecap, but that we have for you guys so you can refer to all these great and important different formulas. So make sure you have the pink sheet, make sure you keep it in a safe place, very useful. Let's go to the actual video here. When we start talking about circles, we have the area of a circle would be how much space goes inside the circle, and the circumference is the distance around the outside. Pretty straightforward. Just as an example to follow along with this, if you have R, remember R stands for radius. So R is the radius, and remember the radius is half the diameter. So if the R is 5, then I want to find the area is going to be pi times 5 squared, which is pi times 25. You can leave it as pi times 25 or 25 pi, or you can decide to do 25 times pi on your calculator, and what I want you to get in the habit of doing is using the pi symbol on your calculator, not just 3.14, because the pi symbol is going to be more accurate. It doesn't round. So this is 78.54 units squared, right? When we find the area, it's the units are squared. The circumference is going to be 2 times pi times the radius, in this case 5. Well, we know that 2 times 5 is 10 times pi, and so again, when you put this in your calculator, I want you to use the pi symbol, which is second, and then the button underneath the clear button, so that it's more accurate. This should be 31.42. You can round units. Not square, because this is just the distance around the outside, not the area inside. So hopefully you've seen these before, you've used them before, just make sure you're careful. If we look at the next example, we have triangles. So we have the area of a triangle is 1/2 the base times the height. So just clarify, the base is the base of the entire triangle. The height has to be when you are meeting the base at a right angle. So the height and the base have to be perpendicular to each other. You would not, if I draw an example of what you would not want to do, you would not want to say that this was the height. This is not the height. The height is in here, not this one, this one. Okay, so sometimes you have to draw in a line and figure that height out yourself. Well, if you look at an example in this case, the area of this triangle, 1/2 the base of 12 times the height of 18. So that area becomes, well, half of 12 is 6 times 18. I'm going to have to do that one on the calculator. 6 times 18, 108 units. Okay? Squared, because it's area. The perimeter in this case sounds seems like it might be a little more complicated. We have this triangle. We still have our height of 18, and our base is 12, which means that this is 6 and 6 here. In order to find the perimeter, I need to know this right here. Well, since we know that the height is perpendicular to the base, then we can use the Pythagorean theorem to find this missing length here, because this is the hypotenuse. So I can do 18 squared plus 6 squared is equal to, well, let's see, 18 squared is 324, plus 36 is 6 squared, for a total of 360. This is what c squared is. So if I take the square root of that, then my c is 60, I believe. No, just kidding. Oh, that's if I was dividing, excuse me. So the square root of 360 is 18.5 And so if I know that this length here is 18.97, so if we have the whole triangle now, we know that this is 12 down here, this is 18.97, and since this appears to be isosceles, we would also get 18.97 over here. So if I do 18.97 times 2, because I have 2 of them, plus 12, I get a perimeter. Remember, the perimeter is the distance all the way around the outside of 49.94 units. All right, a couple special examples. Oh, just kidding, we're still talking about parallelograms. In a parallelogram, same thing, same area formula you would use as with a rectangle or a square, okay? But if you have a rectangle or square, you don't have to worry about making sure that the height is perpendicular to the base. That's already true about a rectangle and square. If it's a parallelogram, again, you have to make sure, just like in the triangle, that the height and the base are perpendicular. Well, if we have this example here, we want to find the area of this parallelogram. I'm going to do the base, which in this case is 8, because we know this would be 8 down here as well, times the height of 13, and 8 times 13 is 104 units squared. The perimeter in this case should be pretty simple. We have 2 8s and 2 15s. So that's going to be 16 and 30, or 46 units. Again, area, square units, perimeter, just one dimension, units. Okay, here are the special examples I wanted to show you about. A trapezoid has this special formula here, and this is actually on that pink sheet that I showed you at the beginning. But I just want to show you how it works. Let's say we give the base, one of the bases, a special, let's call this 5. And so base 2 is the longer base. Remember, trapezoids have 2 different size bases. So that's 5. Maybe this one's going to be 9. And let's say our height is, what's that? Well, let's estimate that to be 4. Why not? Okay. So just to use this formula, same way we use any formula, we're just going to plug everything in. So 1/2 times the height of 4 times the base 1, 5 plus 9, do in parentheses first. So the area is going to be 5 plus 9, 1/2 times 4 times 14. Well, half of 4 is 2. 2 times 14, so the area is 28 units squared. Now, this formula here for hexagon also works for any regular, whoops, wow, that doesn't like me. This works for any regular polygon that you can divide into triangles, okay? Just ignore that part. The apothem that's listed here is this length right here, from the very center of your polygon to a side. And again, just like the other examples, it has to be perpendicular, it has to make a right angle. So let's say that our apothem in this case was 7, and our perimeter, or excuse me, our length here, let's just call it 8, so that if we wanted to find just the area of one triangle, I would do half of the base, 8, times the height. That's sort of like what this is here, right? Except since I have 6 triangles, or a hexagon, I don't want to do it just for one triangle, I want to do it for all 6. So I'm going to use a perimeter of 8 plus 8 plus 8 plus 8 plus 8, or a perimeter of 8 times 6. My perimeter is 48. So to find the area of this, I'm going to do 1/2 of my apothem of 7 times the whole perimeter, so that I take into account the whole hexagon. Okay? I'm going to just do this one out on my calculator. So 0.5 times 7 times 48 is 168 units squared. So remember, it all goes back to making sure that our heights, or the apothem in this case, are perpendicular, using formulas carefully, and following order of operations as well. Good luck.